and you want to learn with us, definitely in next sessions we will try our best to uh, dedicate a slot that could work for everyone. And most of us would able to get chance to learn together. Believe me, we are not going to promise you like we are going to teach you you know high tech algorithms or something like that, complicated algorithm, or making you uh, to win the competition. So purpose is, as always it used to be, just learning. So we'll learn together, we'll try to apply best, you can say, best to our understanding algorithm, and the one that could helpful and be implemented in real world example. So we have Dr. Rosana, as you know, she is a subject expert in this area. So let's have a little bit taste of what the topic is and what are the current scenarios in climate change or something like that, and then we'll move forward with how we'll follow up throughout this datathon. Dr. Rizana, would you like me to share screen, or you are going to do it by yourself?
I think you can share the screen.
Thank
if
you.
that's okay.
Yes, Erum. Yes. Do you need something from my side?
No. We are just waiting for Zana to share her screen.
Okay. Sure. Please.
Yeah.
Sorry, I was trying to share the wrong thing. Apologies for that.
No problem. If you want me, I can do that as well.
That's fine. Should be fine now. Can you guys see?
Yes, it's visible. Oh, so it's loading. Yeah.
Perfect. So I don't know if you want to get started or if I should get started.
You should get started. We will walk through later on.
Okay, perfect. So first of all, thank you for the invite, for being here, and thank you all for being here today on a Sunday as well. And very excited to be mentoring you all in this another WiDS hackathon. It's always fun. It's always like a lot of learnings, and I couldn't agree more with Erum about just using this as an opportunity to learn. I think that every competition that we join more like for the competition of who's learning more. And I mean, it should be about learning and not necessarily about winning. I think that is the majority of the spirit that we have here. So that's nice. So for today, I'll provide you with a general discussion about a little bit about the hackathon, and mostly from the domain point of view. So like about the climate change and energy in buildings and so on. So just so we get general feeling of what the hackathon is about and so on. So like the data, as you guys know, like I was just launched a couple of days ago. So we are all like still learning from that. And but the idea, of course, is that we get started with understanding the problem. That is one of the most important things when we are dealing with whatever data science problem. So for today, I think this is going to be something that Erum will discuss later on. That is about how we're going to be building the teams and how we're going to be making the submissions and so on, and organizing the teams themselves. I don't know, Erum, if you want to talk a little bit about this now, or should I just go more to the main part first?
You can continue. I'll discuss this later on.
Okay, perfect. So let me just move to that slide then. 1 second. Oops. Oh, yeah, it was already here. Sorry about that.
Yeah.
Sorry. We are still preparing everything before us. So yeah, like the idea of this hackathon is to discuss or to tackle the climate crisis, especially focusing on the energy consumption in buildings part. So as hopefully you guys already know, the climate crisis is a real threat to our life, basically in society, and how we've been living in society as a community is something that is being harmful for the climate, so to say. So basically, the climate crisis corresponds to the footprint, the carbon footprint that we produce in our daily lives, and that makes the planet warm. And then, of course, there are many consequences, not only global warming, but other consequences such as extreme weather events and many things that we are already facing, even in the last years, like such as floods and hurricanes and so on. So these are all like consequences of the imbalance of the climate. And by now, we already have like many decades of research on this topic, and it is very clear to us that the climate crisis that we are facing is man-made. So it is something that was created by the way that we are as societies live in the world. Of course, like different areas in the world contribute to this to the climate crisis in different ways. Such as, for example, we have the CO2 emissions from transport, for example, like by flights, many flights that people have now. So there is also, like, of course, energy, the energy sector that is very important. This is going to be where we're going to be tackling in this project. So like how our energy consumption is also affecting the climate through this CO2 footprint. There's, of course, like also agriculture and how we eat, for example, like the sources of food that we have that come from like how we use the land and so on. And this, of course, also affects the CO2 emissions in the planet and so on. So like for this hackathon specifically, we're going to be discussing about the energy perspective of or the, so to say, like the role of energy consumption in this big umbrella of climate change. So the idea here of this hackathon is to try to understand how the energy consumption in buildings, specifically, of course, energy can be of many sorts, but specifically how the energy consumption in buildings can affect, in our case, like we're going to be predicting how the energy, like the forecast of energy, so like how we can predict how much energy is consumed in a building, so we can tackle cleaner and greener solutions and more sustainable solutions as well. So this is more or less the idea of the hackathon. Just to give you a little bit of context why this is important. So to understand why the energy consumption in buildings is has such an impact in climate, you can start thinking of the overall population in the world. So we have now about 6 or 7 billion people in the world, and it's forecasted that by 2100, so in about 80 years, we're going to have 10 billion persons in the world. And this is, of course, depends a lot on how the population grows and so on, but it has been something that is growing massively. And it is for sure, like we have more people in the world, we have more people consuming and producing goods and so on. This all has a footprint, and then everyone, like in different ways, of course, but all of us have a carbon footprint. So if we have more people, of course, we have more carbon footprint, and then it becomes more difficult to tackle the climate crisis as well. But of course, like we also have a lot of like development in the like lifestyle of people. So nowadays we are seeing a huge growth of urban population, especially coming from the developing countries. So this is just like a view from the United Nations, from Statista, that is like showing how especially the developing areas in the world have an increase of the population in the cities. So we are having about 68% of the world population is projected to be living in urban areas by 2050. And that means that especially in the developing countries where we still have like many rural areas, especially in Africa and Asia and in Latin America, we have this growth of people migrating from rural areas into urban populations. So this is just like showing more or less like the projections. Actually, this was for like not the projections, sorry, like the historical growth. So we see that there is like a much more growth in the developing areas in the world in comparison to, for example, Europe or North America. And one important thing to understand is that if we have more people in the world in general, like as in the next decades, and we have more people migrating to cities, basically, what happens is that those people will have to live somewhere. They will probably be working somewhere, and the where they are going to be is our buildings, basically. So that's our understanding, and that means that we see, like especially in big cities all over the world, that we see lots of constructions. There are like a lot of growth in the construction and construction sites in especially like very cosmopolitan centers and so on. And it is expected that by 2060 we have 2 trillion extra 2 trillion square feet of buildings in the world. And that means that basically we are constructing the area of a New York City per month in the next 40 years. So that's quite a lot of construction. Of course, this will have implications in the energy, like because of course all the buildings are going to be having light and so on, and then other amenities, and this is a little bit of what we're going to be discussing in this hackathon as well. So this is just like an overview of how the energy consumption in buildings specifically is related to climate change. Now, when we think about energy consumption, we can look a bit like give like more of a zoom of like how energy consumption is divided by sectors. So of course, like we have in industry, like all the production, like all the processes for producing the goods that we consume in our daily lives. This accounts, this is, I think it's for the United States, if I'm not mistaken. This is also a research paper from UCLA. And this is part of like 1/3 of like the energy consumed by sector comes from industry, which makes a lot of sense because it's like all the goods that are produced come from like some place that is building them and using energy for that. We also have transportation that also contributes to a lot of like for buses from from planes and so on. So we also have energy from there as well, and trains and so on. And then, but still, like the majority of the energy consumption comes from buildings, being them residential or commercial. That means that, of course, like the use that we have for the buildings is different. For example, in houses, of course, we have like more like a refrigeration, and we have cooling, we have heating, and so on. And in other buildings, we might have other like important things, for example, as ventilation and other areas as well. But the important message from this image here is that the energy consumption is actually a very important contributor to the climate change, and specifically the energy consumption from in buildings is still the biggest chunk of the energy consumption that we have. That means that we can, if you want to tackle the climate crisis, we can look into how we can forecast, first of all, this energy consumption in buildings, and then how we can also use this as like looking into more sustainable solutions, because, for example, we can look into efficiency, we can look into greener solutions and so on. So that's more or less the idea of it. So part of what we will be doing in this hackathon is to actually trying to understand a bit more of these profiles of what kind of buildings have what kind of energy profiles and so on. So here is just a starting point for us to understand the big picture, if you want, of this problem. So also, if you look more into like a residential and commercial, if you just put in terms of like a very general things, we can also look, this is more like worldwide, but then we can have a better understanding of like what is the typical profile of energy consumption in terawatts per hour, and also like what are the overall chunks that are present in both of those parts. And then we can see that profiles, for example, for residential buildings are quite different from the commercial ones. For example, we have a big chunk of cooking and appliances at home, whereas in commercial buildings, we have more like a cooling and lighting and so on. So this is something that is important to understand, like those two different profiles, because this is going to play a role, a very important role when you're forecasting how much energy it is consumed by these buildings. So also just looking a bit worldwide, I think, if I'm not mistaken, we're going to be focusing on the energy consumption in the United States, which is from this image here. This is also from the IPCC report. We can see this is like a profile of the energy consumption in the world. And you can see here how much it is, like the color scale here is for like the bluer it is like the highest consumption and so on, and like also the area, sorry. So we can see that the United States and or North America, United States and Canada, along with Europe and also Oceania or Australia and New Zealand, are the biggest energy consumers in the world, and whereas like other areas such as Latin America and Africa and parts of Asia as well, or Middle East and so on, are not consuming so much of the energy in the world. Like the energy profile is still like I would say that some orders of magnitude different than we have in the United States. So it's quite interesting. They're going to be looking into those kind of buildings because it's something that is, let's put it like this, if you need to really focus on some areas that we can really have a clear impact in the climate crisis, we should be really looking to those areas where the energy consumption is like the highest. So the idea of looking to the United States especially is quite relevant for tackling the problem from a climate change perspective. Of course, that ideally, and especially for the countries that are still transitioning to this more urban scenario for the general populations in the cities, it makes more sense that we already transition directly to a energy in buildings that is more sustainable. But of course, the highest impact will still come from the buildings that are going to be if we make this change, of course, like they're having like a more sustainable energy from the buildings that are consuming the most. Like I think that makes a lot of sense. So this is just something to give you a context. And just so you know, like why it's important to also tackle this, according to the World Resources Institute, only so far, only fewer than 1% of the buildings are actually zero carbon today. That means that we still have a lot of work to do, and we have all the sustainable development goals, including having more sustainable energy solutions, like cheaper energy solutions and efficient and so on, and green, meaning as renewable or that has a lower carbon footprint. And to achieve those goals, like we are talking about a scale of 10 years, we really need to tackle this problem more seriously. So in terms of a forecast, it is predicted also like that the electricity consumption is going to be growing because of all the reasons that we already mentioned, like more people in the world, more people moving to cities and living or working in buildings. And then, of course, this is estimated to grow massively in the next decade. And that's why it's important that we tackle this problem. So for this hackathon or datathon, it's very important for us to understand, like from a from a data science perspective and from a data oriented or data driven perspective, what are the key ingredients for the energy consumption in buildings? So for that, we're going to have insights from the data, and our work here in the next weeks or in the next months is going to be understanding what kinds of buildings are out there. So, for example, we talked about residential and commercial, but of course, commercial can be, as you're going to see in the data, as a matter of fact, like a commercial can be schools, commercial can be factories, and those types of buildings themselves have different profiles of energy consumption. In the same way, what kind of material a building has is built. Because, for example, if you have some specific material, that means that the building can heat much faster and can get warmer much faster. And that means that in months of summer, probably people you use more AC for cooling the building, whereas in the winter, maybe they use less heating and so on. So like it's important to have this understanding of what are the different aspects. Also, for example, what kind of characteristics the buildings have. For example, like how, what is the size of the building, and even like what is the electricity profile that they have there, and so on. So like and as well as like a weather conditions and many other aspects. So in the next weeks, and especially in the next session, we're gonna be tackling like this understanding of like what are the features that we have available in our data set, what are the features that are relevant actually, because as you see, there are many features that might not contribute at all for the forecasting of the energy consumption. And it's a little bit of what we're going to be doing. So that's something that's quite exciting. And before we start, I think Erum will now take over to discuss a little bit about the hackathon itself and like how we're going to go in terms of logistics with all the Kaggle competition and so on. I just want to say that it's very important to, in this hackathons, just as like someone that has participated in quite a few so far, that we really try to connect to our team, that we use this opportunity, especially under this WiDS context, so in like a women in data science context. As Dr. Tanzila said very well, like we still don't have many women in this field, and it's important that we support each other. It's important that we learn from each other, and that we take this opportunity to connect to other women in the field, to make friendships and to just keep learning from each other. And as we will discuss in the next sessions, in the next month, basically, we're going to be also seeing how modeling is important. And for now, we're going to start more with the data part to really like get our hands dirty and starting to understand how the data works. And just to finalize, I just wanted to share a couple of resources that can be relevant from the domain perspective. I think Erum will discuss a little bit about this, but one important aspect of working in data science projects is, of course, that we understand the problem we are trying to solve. We cannot just like throw ourselves into the data without understanding what we are trying to solve. So it's important to have a look into some resources. I can recommend the IPCC report. Like the IPCC report is huge, but specifically there is the chapter 9 that is not so big. It's still readable. That is about buildings. So the IPCC report is this report about climate change. There is a new one actually that will give you some hint of how the climate crisis is affected by buildings and so on. So it's a very nice way to start getting familiar with the topic. I also recommend you to have a look into research papers. So you can go to ResearchGate or archive.org, where you can just search for like energy buildings consumption or energy in buildings forecast and so on. So you have a clearer idea of how other people have been tackling this problem. Of course, it's going to be a different data set and so on, but it's still nice to know what kind of like models people are using, what kind of like approaches people are having for this problem. And I also specifically recommend the like also general articles, but especially the Gates notes. This is like the notes from Bill Gates that maybe you guys are familiar with, where he also has like a very nice article talking about energy in buildings. I can also share these links in the chat, so you guys can also have a look. And it's quite interesting article to also give an idea of like how to tackle this problem also in this hackathon as well. So thank you so much. And I think now I'll hand over to Erum to continue discussing about the hackathon and all the logistics of the Kaggle competition. So thank you.
All right. Thank you so much, Rosana, for such informative information, and that was really amazing. All right. So, from my side, let's. Okay, I guess my screen is visible to everyone. All right. So, I'm instructor, so you will see me, the proper processes, how we start. So every time we'll do something. So I know all of you are well aware what is machine learning process, but I would be just making sure just let's follow these steps. So most of you are already working as senior positions as machine learning or data scientists. So I'm just going to give a brief, you can say, introduction how we are going to follow and what is actually machine learning process. So when we do machine learning projects, normally we come across the raw data set, and we always extract information through pre-processing method from that data, like what is relevant to us and what is irrelevant, why to take everything that is irrelevant. So we'll start from data pre-processing and pick up the relevant information from the data set, and then again we'll apply on that, like selected data set will apply uh, you know preparation on data, like what is visualization, and uh, what is the data spread, and what are the important features and how they are linked, and just knowing about data, getting inside story from this data before applying any model, before going into complex model. We'll just look upon what is the actual data set and what is it telling a story, so that we would be in a position to apply relevant model on that, instead of applying everything and then saying like they are not working or they are working, and then we might have to reiterate. So this process is iterative itself. So we'll apply a few pre-processing, collect relevant information, and apply have a data visualization story on that. And if we feel a need data is missing, we need to apply a few more mechanism on that, and we'll go back, and this cycle will m- move forward unless until we we are satisfied with like the data is telling us a real story. So I always recommend, like, no, don't go for directly on the model unless until your data is telling something informative, or the story through data is really amazing, or we can predict something amazing from that. Otherwise, believe me, you might have some problems at validation or at the testing of result or something like that. So once we'll be sure
Oh, apologies. I was actually about to ask whether the it was frozen just for me. I think Erum lost her connection. Let me just check with her what is going on, and otherwise I'll take over from that.
I'm sorry. I guess I have
Yeah,
lost it. I'm so sorry. I
no
didn't
problem.
even realize that I had. So I was just telling like how we are going to proceed with that, and in same fashion we have actually created workshops and flow of this every activity.
Erin, sorry to interrupt
Okay.
you. Could you make the slides like a full screen again?
Okay, let me again do that. Okay, it's visible now here. Thank you. So yeah, so we are clear over here now. Moving forward, so how we are planning to work together. So I'll let you know there. We are going to create different groups, and groups are of your own choice. So uh, you can let us know. We'll share a document Excel sheet with you. You can fill it up with whom you want to create a group. So there should be 4 groups. There will be one leader in every group, and then we'll have a Slack workspace. I know for AI girls, we already have different platform where we are working together, but for AIDA lab, there may be few other teams from locally and from other groups. So that's why we might have always have Slack workspace for accessibility, like where you can share your thoughts, or if you stick somewhere you can post or tag someone over there so that you can get immediate feedback. For every phase, as I have shared with you, we have set a deadline just to make most of us used to be very busy, and it becomes hard when we know like the deadline is in 6-7 weeks. So let's delay it for a couple of weeks, and we may work it in last week. But in datathons, that don't work, and in learning process also. So what we have done is that uh, we have made it just like let's set deadlines for each phase and discuss with each other, like are we done with that, and if we couldn't do that, what are the difficulties we are facing, so that we would able to solve them all together and move forward with each group, right? And learn with fun. So we'll have 1 hour workshop every week and showcase for the other hour, or maybe like if it requires more, we can have one-to-one session, we can have a group discussion or whatever at our own end. But what we can do is that we have like it's a modeling week. Let's have let's learn different best practices of how to build model, what are the easy way to build a model, and deploy it and test on the data. And then next half hour we can see like what are the technique have been applied for data engineering, for data preparation. So it will be 2 ways of learning. So 1 hour we would provide you mentoring and workshop, and 1 hour you will teach us what are the methods you have applied or you come across, and how those methods are very effective and helpful while solving this problem. And the one last thing is we are going to collaborate instead of compete. And believe me, I always say we are not over here to compete, we are going to learn. So and you will get the chance to learn a lot uh, during these couple of weeks. Again, you have already seen this brochure, and that might be reading these table used to frighten me every single time from where to start and what is written over here. So that's why I have already shared with you our like machine learning process. So we have added machine learning process in this table. So 9th January today we are going to just have introduction, what the problem is, how we are going to start, and how to prepare data. From next week onward, we'll have, on 16th of January, we'll have machine learning in environment crisis. And what is the aim of this workshop is, it describes the machine learning process starting from data preparation, validation, and it will provide you insight, like on the most famous, you can say, or well-known machine learning algorithm, and how we can apply those algorithm in generic problem. In third week, we'll have a machine learning along with deep learning. So over here, we'll move forward from basic machine learning and data science to deep learning, and maybe few of transfer learning, that, like, if time allows us. In fourth week, I'm just reiterating over here. So like from 15th of January, we should try to done with data preparation at least, so that all of us would be able to start working on machine learning models. And on 30th, we'll have machine learning and transfer learning model in climate domain, like just extending this one. And we should be in the position to present our results from basic machine learning model and deep learning model, and our data is just ready to apply transfer learning mechanisms. 6th February would be actually model validation method, and we might have to reiterate these processes again, because we might not able to get good accuracy at that time. So we'll have 2 more weeks just to uh, address the problem. Like, our ideal situation would be, we should complete everything by 6th February, like just to submit the data, our results. But we can work on improvement. So for the rest of the 2 weeks, we'll have those session, but there wouldn't be any workshop. So we'll come across maybe some specific problems, or some most of the time, you stuck over there, you are unable to create CSV file, you are unable to read the logs file, you are unable to submit the result, uh, you know uh, you are not able to set the GPU or something like that. So for next 2 weeks, we'll just work on the problem initiated by you, and obviously we'll have a Slack channel, so you will communicate us through that, and we'll prepare resources for you, so that we would able to sort them out all together. Okay, so any question up till now? Okay. If there is no question, then again, that's the third time I'm saying again. Problem understanding and team formulation will be done till 16th of January. Data understanding and preparation would be 16th of January, same. Sorry, data understanding. Preparation mean data engineering and everything, like it's ready to apply the model. 23, modeling, including everything, like deep learning, machine learning, transfer learning, by 30th January. On 6th, we will be discussing model evaluation, and ideally it should be submitted by 22, but that is not possible, so we will still have 1 week lag time. So we might not be in rush on last moment of submission. All right, so any question up till now? Then I'll move forward with all perfect. Puja says, okay. Now I'm going to share a Datathon page with you, and I know most of you would aware about, like, how to start with that. But just be part of the process. Let's revise it all together. So first of all, you must have received an email from WiDS Datathon to join it. If you haven't done that, you can simply type in WiDS 2022 and you will find you will find link over there. Right, that's the WiDS Datathon web page. So you can go through that and you will find how to join, right? And it will direct you to join this page. Over here we have a description, what is it about. So as Dr. Tenzila and Dr. Rosana has already shared with you what is it about and how we are going to proceed. So it's environment crisis. You can read the background. Climate change is globally relevant. That is actually information relevant to WIDS, Women in Data Science. So climate change is relevant. We have already seen how it, problem from where it is coming from. So addressing climate change involves mitigation. What mitigation? Greenhouse gas emission and adaptation, preparing for unavoidable consequences. So we are living in modern era and we can't control the factors, but we need to know how we can mitigate that gap. And mitigating that gap is greenhouse gas emission along with preparation of unavoidable consequences. So mitigation of greenhouse gases emission require change to electricity system, transportation, buildings, industry, and use. According to report issued by International Energy Agency, the life cycle of building from construction. So you can go into detail. I don't want to bore you over here. You can go through that and you will see like why the topic is very important. Then we have overview, the data set and the challenges. So most of the time I've been part of a previous WiDS Datathon and closely observed the Datathon 2 years before. So most of the time whenever we get a data, you can say the data set, so it itself used to be a huge data set and it requires a lot of feature engineering. So our major goal like effort spends mostly on data preparation, because data used to be huge in number and in raw format, and you don't know which feature is important and should we keep it or should we discard it or something like that. So the dataset was created in collaboration with climate change AI and Lawrence Berkeley National Laboratory, Berkeley Lab. WiDS Datathon participants will analyze difference in building energy efficiency, creating model to predict energy consumption. So that's our goal. Differences in building energy efficiency and creating model that could predict energy consumption, so that we would able to address this gap of mitigating greenhouse gas along with the unavoidable consequences of that. So we'll use the data set consisting of variables that describe building characteristics and climate and weather variables for the regions in which buildings are located. Accurate prediction of energy consumption can help policymakers target retrofitting efforts to maximize emission reduction. So that's about what is required, who can participate. So dataset and challenge will be accessible to both beginner experienced participants. For those who have never tried machine learning, will be releasing a series of guides, tutorials and webinars. So you can check it over here. Like we are conducting workshops and webinar at WIDS KSA chapter. So there almost every single chapter is trying to help you out with various resources. So you can start with that. Many WIDS ambassador host Datathon workshop, which participant will be able to receive mentorship for teams and your teams and hone their data science skills. So you can learn from that too how it works. The WIDS Datathon will run until 26th of February. So you see, we are closing it by 20th. We will still have 6 days to improve our results. Data analysis can be completing using your preferred tools, tutorial sample codes, and the other resources will be posted throughout the competition on the WIDS website and the Kaggle discussion forum. So let me open this as well. You will then upload your prediction for a test set as a Kaggle, and these will be used to determine the public leaderboard ranking and the winner of the competition. So let me show how it works. So basically that is a leaderboard, and there will be scores of every team. Like we have different submissions along with score and number of entries. So score is 19.13 and entries are 18. It was submitted 4 hours before, and then 24 and so on. So you can submit your result, and these will be basically test from leaderboard ranking. Winner will be announced on March 7, 2022. Like last date is 26, and within within a week, result will be announced. And then acknowledgements are these. Basically, they have collected data set. They have been partnered with WIDS team to make this Datathon available for all of us. Then for evaluation metric, we have a root mean square error that is actually used to measure the differences between predicted values by a model and actual observed values. And submission format is actually site E, UI and ID, and you separate them with comma. For example, ID is 75757 and site ID is 1.3. For leaderboard standings, 51% percentage approximately used to be shown, not 100% of data is shown. So once you submit your result, you might be on a 10th position or 20th position, and when they recalculate your position can you can rank up or maybe rank down, because they're randomly picking up 51 to 49. Then we have different FAQs over here, like about the teams, and these are very that's very important to read them out. I have seen, like we neglect small things, and then you suffer maybe by last week. Last time we were not able to basically a team wanted to change a group member, but they were not able to change that because that was already written there. So we had faced a few problems while forming the teams, and then submission relevant and something like that. And despite trying many times, we could not get help because those were written clearly in FAQs and we ignored that. So I would request, like, just skim read them, what are these FAQs, and just follow these guidelines. Like these are very very important, although we most of time we neglect them. And What are the team formulation guidelines? Which Datathon phase? I teams formed on Kaggle are open to individual or teams up to 4. At least half of each team must be individual who identify as a woman, like two female and two male can join group up to make a team. And each team member must be officially registered at uh, where's Datathon. Like you can't directly register from this link, start registering through the Kaggle. So you need to submit a form at web page, and then you can do that. So that is also important. We missed that in previous Datathon as well. You may merge with our combined team until 23rd Feb. So that also happened last time. So for example, last date of submission is 26. So you can't go and say like on 25th we are going to merge the team. So the deadline is 23rd. So either do it now or maybe you can do it later on. Sometimes people don't merge the team because different teams are working in different, you can say, algorithms, and they merge maybe last week of, I don't know. Whenever you feel comfortable you can do it, but make sure do it before 23rd of February. Once you join a team on Kaggle, you can't remove yourself from the team. So that's what, everything is answered over here. And we faced 3 problems last time with 3 teams. We could not remove one member from the other team. We could not merge the team after due dates, and the few teams were already having like more than females in one team, so they were not able to, although they were doing good, not able to merge the team. So you see, these FAQs are very important, so you can go through each one of them and check the basic rules. For a Datathon phase 2, that is also really important. Like for researcher, you can write a research paper from whatever your findings are, and the deadline for that paper is 30th June, and you need to submit that till that time. And that research award is not linked with highest accuracy. So you must be like, I also don't find like the better accuracy can be the better model. For example, if your approach is good but accuracy is not up to the mark, and lower accuracy is more applicable in real world application, so there are chances we can get research award. So research award is not linked with evaluation metric. And Datathon timeline is on 6th of January. Registration were opened, and on 2nd, access to the recording where the woman event. January 28th, you can have there will be a webinar, data science and climate change, with expert from verbs. And last year I remember we attended that, and that was really helpful. Last year we had the basically WiDS Datathon was in healthcare perspective, and there were actually medical experts, and who gave really insightful information just in filling the data, which we were ignoring. We as engineer fill up the data maybe with mean value and specific engineering methods, but they were not considering that what we can say, an accurate method of filling the values. Because when you fill value with 0, it means you are actually bringing more noise in medical data. For example, how your sugar level could be 0, right? So that was really helpful, and I would request just register for that and try to join. And I'm hopeful even during this time we'll have insightful information. Again, we have seen entry and team merge deadline. submission and then result. For second phase, it will start from 8th March. That is actually research paper submission. And it used to be hardly 3-page paper. And deadline is 30th June, 11:59 is PST time. And I guess 2022 would be announcement date. Then we have tutorial. We have already discussed a lot on that, so I'll not go into detail of that. Prizes. So first place prize is actually 4,000 USDs for a team, not for individual. Second is 3,000 USDs, and third one is 2,000 USDs. For research, first place is 4,000, second place is 3,000, and third place is 2,000. All winners will be recognized on WiDS social media channels. Special thank to Kaggle for providing and distributing this amount. That's just, and these are the partner. I don't think so we need them. And over here we have, tools and virtual collaboration, Slack, Discord, Gather, or Zoom. All right. Any question up till now? Is it too boring?
Hi, Erum. I think there was a question from Lee asking about these workshops that we are organizing with the Prince Sultan University, whether we need, if someone was registered for the workshop today, whether they already get the links for the next ones, or whether they have to register. I think they have to register for the next ones as well, right?
Yeah, exactly. And another announcement is that we are going to like, if it's okay for everyone, we are going to have next sessions from 2 to 4 p.m. UTC. I guess that would be easy for us. Feature engineering with greatly important in the challenge second. Okay, yeah, I believe. Oh, all right. So please let me know if it's being too boring. I know, but I also don't like a person is just talking and rest are just imposed to listen. But believe me, these are important, because you ignore these things and you start building model. I have seen that. Like, we majorly focus on building model, and then we have to come back to the feature engineering. That is very important. And then first is feature engineering, and then how to deal with that. We normally fit everything in one size, like, for as I have just shared with you, for a missing value, to deal with missing value, we substitute with standard method, but that doesn't work in every situation, because it actually create more noise in your data. So we need to be careful while uh, uh, filling this up, or dealing with specific topics. So that is the starter guide, and that is really amazing. So I am just going to walk through that, and I'll not take much of your time on that. I'll share this with you. Let me go to just data first, and then we'll move forward for that. That is also important. So when you open up the Kaggle, you will have overview. You can go through that too. I would just emphasis on you just to do these, like description, evaluation, and FAQs. These are must read, and please do that. Then we have data. This is overall description of data. Then we have code. So for code, most of people have already added publicly available code, and these used to be very helpful. So you can sort them out: most voted, recently created, because most of the time we used to have already gone through every single file, so we are just going to look upon the recent one. And then recently run, best score, relevance, something like that. So you can go through that, and just pick any one of that, and you can build your code about that. So that would not be like, I don't consider it is a cheating, or you are stealing their idea, because if that is publicly available, it means you can build something on top of that, instead of you go there and start building everything by yourself. It will waste your time, and you might have to put a lot of effort to work on that. So my suggestion would be, just pick up, like, go through the file and pick few one and start working on that. So while you will explore them, you will get to know like how these are working. On top of that, you can build your own model. So I don't say like submit their code, but I would recommend just take them as a starter guide, as Wiz already have shared it. And if you face any problem, just go through the discussion. If something is already like there in discussion, so most of the time, whatever problem you are facing, mostly people used to face that problem, and they post over here and they get replies from expert also. So discussion is also helpful. For example, looking for a team mega thread welcome, that is the thread from WIDS itself. So they have written over here, like, if you see any problem, that these are the welcome notes or something like that. So you can always go through discussion and check. Data dictionary clarification required, that is very important. And I read that, and you know uh, they have mentioned a clear view. We might miss this up, like what does mean by that and how we use it, right? And then leaderboard rules, you can read them if you want. They are more or less the similar one we have already discussed. Teams, you can check your teams and check if you have submitted something. Okay, from code I have picked this file, and then if you see, I went over there, edit it. Now this has become my copy. I can even write over here, that is a local copy for myself. So I can say it's from Erum, right? And it's really good. So here is actually description. Then we have goal. Then we have a data. In data, we have 3 files: train CSV, test CSV, and sample submission. So for train, that is the part of data, as from train data set, we actually apply machine learning algorithm on that. From test, we check whether uh, you know uh, models are working fine or not. And that is the sample submission with 2 columns. We have already seen that. So these are columns, right? So we have different columns like ID, years vector, state vector, building classes, facility type. So you can remove them, like irrelevant features. You can keep everyone, but make sure you can't remove the one mentioned in submission. So you can't remove ID, and the other one was, I guess, state underscore UDI, I guess. So we can't remove them. Other than that, like if you see, there are irrelevant, or these temperature should be the one column. We want we don't want average temperature, we want individual temperature, because average temperature is generalizing and we want to go into specification. So we can create multiple columns from that as well, right? And then for evaluation, we have weight and biases. And they have explained really well what does mean by weight and biases. It's a set of machine learning tools that helps to build a better models faster. Kaggle competition require fast-paced model development and evaluation. There are a lot of component exploring the training data, training different models, combining trained models in different combination, that is called ensembling, and so on. So, most of the time we do these, like exploring the data and then, building the model and then combining different model. So ensemble is really good, like you combine different models and then, uh, bring result into simple model. Lots of component, lots of places to go wrong, lots of time spent debugging, as we have already discussed. And how it can be useful: quickly track experiments, version and iteration. For example, you have built a model on some data set or on some features previously, and now you want to uh, go back and use the similar one. So you can track, you don't need to make multiple copies, you can go and pick that particular version as well. You can reproduce your model, like you have done some model on neural network and you want to reproduce with other feature. You don't need to recreate the whole document or whole notebook. You can do that here. Visualize the results. So you can visualize and it will help you out, like what is the spread of data and where is noise, and how we can tackle with those we can say noise problem or something like that. Same, we can spot regression, that is the similar one. Share the finding with colleagues. So you can simply share your finding, what are your results. So you don't need to share the complete file and they have to have particular tools to run the file. So you can simply share your file and they can just log in and uh, uh, view that. So you can check out this kernel to learn about more about that, and that is also very amazing. So you can check this as well. You will have you must have this copy, but I'm just sharing here. Okay, now we are going to run this code. So we have from Kaggle secret attached. A user secret client. We are importing from Kaggle secret, and then we have assigned a user client class to this one. Basically, we wait and bias we are using this, and we have secret keys, API key, login key is the secret value, and and how you will get that, you can get it from this link. I have not created the account over here, but if you have, it will just link you, like we normally use GitHub or Gtalk, GitHub through Gmail. Okay, so I'm not going into detail at moment. Maybe in future session I will have a proper demo on uh, uh, this tool as well. So we don't need to go over there. We simply we can import NumPy, we can import pandas, we can import pre-processing. So these are the libraries already available in Python, so we don't need any dependency for this one, right? For basic, you can say in data pre-processing. That is for graph. So matplotlib, if you want to uh, you know uh, create template for visualization, you can do that. So we can create these libraries for visualization. Sharp is normally used for what we can say, just to visualize the results for later stages. So at moment we don't need a sharp at moment, right? So if you simply import these libraries and just Yeah, this is also important. Let's not import this one, and WAN DB also, right? So that is sufficient for data processing. Even uh, like LGBM is a deep learning model, we can ignore this also if you want. Like at moment, let's stick with normal, basic machine learning models. Here we are importing our train data set, test data set, printing. You already know printing what is and why it's showing error. PD is not defined. Actually, I have not executed this cell. It is just showing how many number of rows and columns in each uh, you know uh, data set. So we have more than 70K for train and more than 9K, like around 10K for test. And there are 64 features or columns. There are 63 column because predicted element is not here. Then we are just checking the columns itself, state name, building class, facility, and everything. So these are 64 columns. Then we are plotting missing values. It will just show us how many missing values are there. So you can see more missing values are here. Let me see if I can zoom this a little. This column has more missing value, that is uh, energy state rating, and then these columns have more missing values, right? So most of the time what we do is that if more than 60% values in certain feature is missing, so let's drop it, because in either case that will not helpful for our prediction. And if that is a not you can say important feature, so it's good to remove it. So null value count air built, that is negligible. So I don't know like whether that would be helpful or not, but we can say we can remove this one. Energy start rating, there are 26K missing values. Wind max speed, peak wind speed, then we have multiple uh, these are the feature along with the count of missing values. And basic feature in training, along through basic feature we just come to know what is the minimum value, what is the maximum value, just to see whether there is some that is just what we can say story about the data. We just come to know what is the spread of data, what is mean value, what is standard deviation. So as you know, standard deviation is how one entry is uh, dif- like different from the other value, like what is the gap or differences between one entrance to two entrance. So air factor, you see there is, that is a negligible, but for floor area that is a huge value, but that is actually different kind of variable, so we might consider this is okay. In air build we have 37 as standard deviation, which means like from 70K values, every value is at different point with the number of 37, with the count of 37. And this in this way we might able to decide better like what is the spread of data, how data is working, like how it will be helpful. Then we have variable distribution, how the variables are distributed with certain values, right? And then we have again the plot on that. That is important. Feature of training and testing. So over here we are changing our feature to numpy, like we are converting them to the numeric value so that certain operation would we would able to perform that. If you don't do that, you might not able, you will find an error like it's not in form of array or numpy, so you has to change them, convert them into numpy. So these are actually, that is, yeah, that is the function to that is the function for the feature engineering, right? So we are converting feature from train to numpy, test to numpy, and then we are plotting feature size is this one. We are defining color that of both test and train graph, adding title. So these are actually, you can say, class functions for the feature graph plot, right? Again, that is also a function. A numeric distribution and categorical distribution. In this, through this we can figure out like uh, what we can say, the distribution of each feature separately. Yeah, from numeric. So you can see like there are distribution of features, then categorical values, where categorical distribution of the features. So we have 64, it will may not. Then we have categorical are the value which are non-numeric. So you can operation is similar one. Then value imputation, that is the filling value. So you must be very careful when you are filling the missing value. So there are different methods. You see over here we are filling mean value, again we are filling mean value, right? So we are filling these columns with missing value. So you see, let's go back to the missing value plot. So if you have any question, please do ask me. So we have, you see, these are the feature where we have missing value, and now we are filling them with mean value. So let's say we have year underscore build, energy underscore star rating, direction max wind, something like that, days with fog, and now we are filling them with so you see we are filling them days with fog, mean. So we are filling every single value with mean, right? And we are doing same with train and test, right? Label encoding. So label encoding is also, encoder is also important, because sometimes we, that is for as a black box. Let me explain you. So it should be integer 8 or integer 64 bit or float 8 or float. So we to make the value consistent in perspective of storage, we normally make a single unit for that. So it could be 8, it could be 16. So normally for numeric value, int 8 transformation is sufficient. We don't need to go like for the value maybe more than that, maybe for in 16 and so on. So now we have weight and biased artifacts. So that is really a good example. We have the data set, then we have a classification, then we have a classification model, and basically this architecture diagram tells us the story how we can share or automate. I'm not going, as I have told you, with that one, because for now I would like all of you to skip this one, do all feature engineering, do everything with standard method, and see what are the result, and then we'll move forward with deep learning, like writing our own algorithm, transfer learning, writing and our own algorithm, and then going, these tools and techniques, because if we go there we might not able to learn. So our purpose is to go through the basic process and then moving forward with these automation. All right. Sorry, I have muted myself. That's it from my side. If you have any question, please let me know.
Thank you so much, Ms. Erum and Dr. Rosana, for your time and the wonderful presentations and